Hi, this is Dr. Diana Songsong, and we will now proceed with our module in efficiency. So for the first part, we will look at linear programming. The question is, how do we use mathematics in giving us efficient solutions that yield optimal results? So when we say optimal, it's either we want to maximize or minimize something. So for example, there are problems wherein we have to maximize the profit, and minimization problems. For example, we want to minimize the cost of producing certain units. Okay. So what is linear programming? This is a mathematical method that is used to determine the best possible outcome or solution from a given set of parameters or list of requirements, which are represented in the form of linear relationships. So the basic components of a linear programming problem would be the decision variables, objective function, and the constraint. So you will be able to understand these terms in our examples. So for example, we have this problem. Consider a chocolate manufacturing company which produces only two types of chocolate, milk chocolate and extra creamy chocolate. Both chocolates require milk and chocolate only. To manufacture each unit of M and E, the following quantities are required. 1 unit of milk chocolate requires 1 unit of milk and 3 units of chocolate. Each unit of extra creamy chocolate requires 1 unit of milk also, but 2 units of chocolate. The company kitchen has a total of 5 units of milk and 12 units of chocolate. On each sale, the company makes a profit of 6 pesos per unit M sold and 5 pesos per unit of extra creamy chocolate sold. Of course, the company wishes to maximize its profit. We want to know, if you're the manufacturer, how many units of milky chocolate and extra creamy chocolate should it produce. Okay, so we will start with our linear model formulation. For the first step, we need our decision variable. So in this case, our decision variables will be x and y, and this will represent the number of units of, so in this case, x is the number of units of milky chocolate that the company should produce, and y is the number of units of extra creamy chocolate that the company must produce. And then, so that it will be easier to analyze our problem, we want to put everything in this table because there are a lot of given things. So first, we have the profit. So that's why I have a column here for profit. So it says here that 6 pesos for each unit of milky chocolate. But since we will produce X units of milky chocolate, what is the profit from that? It is 6x, right? And similarly, if you have 5 pesos per unit of extra creamy, but you have y units of this, how much would be the profit? The profit is 5y, correct? And then let's look at the requirements here. Milky chocolate requires 1 unit of milk. So therefore, 1 unit of milk and 3 units of chocolate. So that means, so this one, you need, for X units of milky chocolate, you need X units of milk and 3X units of chocolate. Similarly, for extra creamy, you have 1 unit of milk and 2 units of chocolate. So that means you need y units of milk and 2y units of chocolate. Okay? Now, what are our constraints? Our constraints is that the company has only 5 units of milk and 12 units of chocolate. So what does that mean? So if you look at this, the amount of milk that you would be using is x plus y, and the amount of chocolate that you would be using is from this. It's 3x plus 2y. Since we only have 5 units of milk, that means that the amount of milk, which is x plus y, should be less than or equal to 5, and the amount of chocolate, which is 3x plus 2y, should be less than or equal to 12. But of course, since x and y represents the number of units, it has to be greater than or equal to 0. So again, in this problem, this x and y here would be our decision variables. This will be our constraints. And what would be our objective function? Our objective function is, recall that what do we want? We want to maximize. So here, we want to maximize the profit. And what is our profit? Our profit is this one, 6x plus 5y. Understand? So this is our objective function. Okay? Let me just rewrite it here. Our objective function is maximize 6x plus 5y with the following constraints. X plus y is less than or equal to 5. 3x plus 2y is less than or equal to 12. And both x and y should be greater than or equal to 0. Okay, so check. Let us now find the solution to our problem. We will be using Geogebra for this method. This is the graphical method. So first, we have to input our um, inequalities. Make sure that make an account, okay? You make sure that you sign in. Okay, I don't know, but when I tried it without signing in, it didn't work. Anyway, so let me just type in my constraints, 3x plus 2y less than or equal to 12. So as you can see there, it automatically gives you the graph of that inequality. X plus y less than or equal to 5, and then enter. And then of course you have x greater than or equal to 0, enter. Y greater than or equal to 0, enter. Now, what we want is the intersection of this system. So as you can see, it's a bit messy here. Actually, you can change the color here. Here, settings, you can change that. Oops. Again, settings, color. There, right? So D became pink. All right. Anyway, just so that you know how to do it. Of course, you can change all of the colors there, but I will not do that. We are only interested in the intersection of all these sets. So what you need to do, you have here your um, labels. This is for A, B, C, and D. You want to find the intersection. So what you need to do, look at the label. So what you do is A and then type in double ampersand, the end sign, okay? This one, double ampersand. Use your keyboard. When you do that, it will become like the in logic, right? It will become and. All right? So A, B, double ampersand, it will be and. C, double ampersand, D. Okay? Enter. Now, I want to show only letter E. So, I will click this so that there will be no color. There you go. So, you can now see your region. So from here, you can see that the points of intersection are 0, 5. This one is 2, 3. This one is 4, 0, and 0, 0. Now, it just so happens here that the points of intersection are nice. Although, of course, you can stop at this. Our point here is we're interested with the points of intersection. However, if it happens that the points are not that obvious, because in this case it's an integer, right? I will also teach you how to get this intersections using Geogebra. Okay, so what you need to do is to type the equations only. So 3x plus 2y equals 12. So just change everything to equations. Alright, x plus y equals 5, x equals 0, and y equals 0. Okay, once you have that, for example, this one, you have your labels. This is the intersection of equation 3 and equation 2. So you type intersect, parenthesis, and then your two labels, equation 1, equation 2. See? It give is my correct? Oh, this one, equation 1 and equation 2. There you go. That's point A, 2, 3. This is equation 3 and equation 2. So, intersect equation 1, equation, what's this? 3 and 2. So, that's 2 and 3. There you go. That's 0, 5. What else here? This is, oh, I did not have. This is F, right? Y equals that, right? Y equals 0, correct? Y equals 0. So, intersect, although of course that's obvious, I just want to show it to you. Intersect, this is Y, and from here, what is that? Equation 1. Enter. Oops, enter. Oh, I'm sorry. It's the Y equals 0 is F. So it should be F. How come it's not working? F is Y equals 0, right? I don't know why it's not working. 1, 2. Anyway, let's try intersect. What else? Equation 1, 2, 2, 3, 1, and equation 3. There you go. You have 0, 6, but it's not part of our region. Okay, so we only want this point. A, B, this is C, and then 0, 0. Okay. Okay, so from our corner points, we will now determine which one will give us the maximum profit. Okay, let me just write down my corner points. So first, A is 2, 3, B is 0, 5. Of course, you have 0, 0. And then you have 4, 0. What is the profit for the point 2, 3? So remember that our profit is 6x plus 5y. So that's 6 times 2. Let's substitute 2 for x and 3 for y. So that's 12 plus 15, 27. If it's 0, 5, that's 5 times 5 or 25. Of course, for 0, 0, the profit is 0. And then here for 4, 0, so that's 6 times 4 equals 24. So this one, 27, is the highest profit. So that means that we have to produce 2, 3. This is for X, this is for Y, right? 2 units of milk chocolate and 3 units of extra creamy chocolate to get the maximum profit of 27 pesos. Next, try this cargo problem. A cargo forwarding firm is planning a major fleet expansion and will purchase a maximum of 15 new trucks. These vehicles are supposed to provide at least 36 tons of additional load capacity. One model holds 2 tons and costs 1.5 million. A second model holds 3 tons and costs 2.4 million. How many trucks of each model should the firm purchase to provide the additional load capacity of minimal cost? What is the minimal cost? So again, we have our formulation, our model formulation. We are given the cost per truck, the capacity of each truck, and the requirements that we have. Let's put that in our table. Of course, our decision variables would be the number of units of model 1, X, and then Y. What is the cost of X units of model 1? 1.5 million for 1 unit. So cost here is 1.5x. Here it's 2.4y. What is the capacity of model 1? It can hold 2 tons. 1 unit can hold 2 tons. So if I have x units, the total capacity is 2x. And then here it's 3y. The requirements will give us our constraints. We want to have maximum of 15 trucks. How many trucks do we have here? X plus y. But since we want the maximum to be 15, this one should be less than or equal to 15. And then total capacity of at least. What is our total capacity? This one, right? 2x plus 3y. What's the meaning of at least? The smallest should be 36. And of course, we always have x, y greater than or equal to 0. So again, we will go to Geogebra to find the corner points. Alright, let us now use Geogebra to find the graphical solution. What's our constraints again? X plus y less than, x plus y less than or equal to 15. What else? 2x plus 3y greater than or equal to 36. 2x plus 3y. 2x plus 3y greater than or equal to 36. And of course, x greater than or equal to 0, y greater than or equal to 0, And then again, I have A double ampersand B double ampersand C double ampersand D. Then I will hide this so that we can only see. Let us drag. There you go. Okay, so what are these points? This is 0, 12, 0, 15, and what's this? 9, 6. Okay? I forgot to mention our objective function. Let's see, let's go back. What is our objective function here? We want to minimize the cost. And the cost here is, what's that again? Here it's 1.5x, here it's 2.4y. So therefore, we want to minimize 1.5x plus 2.4y. Let us now get the corner point. So from what we did in Geogebra, our corner points were 0, 12, 0, 15, and 9, 6. And our cost function is 1.5x plus 2.4y. This is actually in millions, okay? Because 1.5 is actually 1.5 million. Therefore, the cost for corner 0, 12 is 2.4 times 12, so that's 28.8. For point 015, that's 2.4 times 15. And then lastly, this is 9 times 1.5 plus 2.4 times 6. You will end up with 27.9. But since what we want is minimize, we want to get the smallest value of the cost, and it will occur here at the point 96. So therefore, if you are the truck company, what does this mean? This means that you have to buy 9 units of Model 1 and 6 units of Model 2. Okay?